We are going to explore the topic basic block and flow graphs. What is basic block? A basic block is a group of statements in a program that are executed one after another without any jump or branch inside it. Control enters only at the beginning and leaves only at the end. For example, think of it like a straight road. You enter from one side, then you go straight without turning anywhere, and you leave only at the end. That is basic block. So you can think of a basic block like a small contiguous piece of code that always run completely from start to end. In simple word, a basic block is a straight line sequence of instruction with only one entry point and only one exit point, which means control always enter the block at the first instruction, control leaves the block only after the last instruction. There are no jump into the middle of the block and no branch inside the block except at the end. Why this basic block? Inside the basic block, there is no control flow decision, so the compiler can do simple local optimization safely. For example, constant folding, algebraic simplification, or register allocation, knowing the instructions will execute in order. Next, rules to find basic block. In step 1, identify leaders. A leader is the first instruction of a basic block. The first statement of your program is always the start of a basic block. We call it a leader. Next, any statement that has a label is also the start of a new block, that is leader. Any statement that comes immediately after a jump instruction like go to, if or call is also a leader. Once we find all the leaders, we group the lines between one leader and the next leader. That becomes one basic block. In step 2, group of statement into basic block. Each leader begin a new block and the block continues until the next leader. What is flow graph? After dividing the program into basic block, we draw arrow or connections showing how the control moves from one block to another. That connection is called a flow graph or control flow graph. Each block becomes a box, that is node. Each arrow shows which block can come next. Coming to flow graph connection rules, if a block ends with a conditional jump, for example, if a less than 10, go to label 1. Here one arrow goes to the jump target block, another arrow goes to next block if condition is false. In case if a block ends with unconditional jump, that is go to, only one arrow to the jump target. If a block ends normally, that is no jump, arrow goes to the next block in the program. If it ends with return or stop, then no arrows, end of the program. These are the rules of flow graph connections. Let's take a simple example, 3 address code, A equal to B plus C. If A less than 10, go to label 1, D equal to A into 2, fourth line go to label 2, next fifth line, label 1, D equal to A minus 2, label 2, E equal to D plus 1, in the 7th line, return E. The given 3 address code, we have to find leader. Rules for finding leaders. The first statement is always a leader. The given 3 address code, first statement is a leader. In second rule, any statement that is the target of a jump, that is label, is a leader. In the second line, jump target or leader. If A less than 10, go to label 1. Label 1 present in the line 5. So D equal to A minus 2 is a leader. Rule number 3, any statement that immediately follows a jump or branch is also a leader. Statement after any jump is a leader. After line 2, if A less than 10, go to label 1. The next line is line 3 is a leader. As per rule 2, jump target or leader. Here go to label 2. Label 2 is present in the 6th line, E equal to D plus 1 is a leader. So leaders are 1, 3, 5, 6. Now make the basic block. Now we divide the coding using these leaders. Start from line 1 and go still before the next leader, line number 3. It ends with the conditional jump. If A less than 10, go to label 1. Then write the basic block 1, A equal to B plus C. If A less than 10, go to label 1. Next, draw the basic block 2. Start from leader 3. that is line number 3, and goes till before the next leader, line number 5. End with an unconditional jump, go to label 2. Then basic block 2 becomes D equal to A into 2, go to label 2. Next, basic block 3. L1 is a label, so it starts a new block, no jump here, so it will go naturally to the next block, which means basic block 3, label 1 D equal to A minus 2. Basic block 4, it starts at 6th line. L2 is a label, last block, end with return, so stop the program. So basic block 4 becomes L2 E equal to D plus 1, return E. So totally we are having 4 basic block. In the next step, draw flow graph using arrows or connections. Now draw the flow graph using connection rules. So starting basic block A equal to B plus C. If A less than 10, go to label 1. If a block end with a conditional jump, like if A less than 10, go to label 1. Label 1 contain the statement D equal to A minus 2. So one arrow goes to the jump target block line 1 and another arrow goes to the next block if condition is false. In the second block D equal to A into 2, go to label 2. If a block end with unconditional jump, that is go to only one arrow to the jump target. So that is L2 is a label, it contains the statement E equal to D plus 1. If a block end normally, that is no jump, arrow goes to next block in the program. If it end with return or stop, then no arrows, end of the program. So finally, this is our flow graph. Now I summarize the basic block and flow graphs. A basic block is a group of statements that are executed one by one without jumping in or out in the middle. To find basic block, we first find leaders, then group statement between leaders. A flow graph shows how these basic blocks connect to each other with arrows. Arrow represent control flow which basic block execute next depending on condition or go to. This structure helps the compiler understand the logic and perform optimization easily. I hope you all have understood the basic block and flow graphs. If you have any doubts, feel free to leave a comment in the comment section. Thank you.